Greetings from the Hermitage, and welcome to this presentation on solving equations that involve both multiplication and addition. This is the second presentation that we've had on this topic, but recall that in the first presentation we used nothing but integers, whole numbers. In this presentation we'll extend this techniques to working with equations that have denominators in them. And the equation that we're going to use to demonstrate how to solve these equations, and we'll do it two different ways, and it'll be your choice when it comes time for you to do the problems, which one you want to use. In this first technique, we'll harken back to the first video on this, and in that video we showed that it's easiest to solve these equations if you get rid of the constant term first. Let's go ahead and do that. 5x plus 3 over 7. And to get rid of that constant, what we mean is to zero it out. And to zero that out, we use the additive inverse. And the additive inverse says to add the opposite. And since I added a negative 3/7 to the left-hand side of the equal sign, I'll do the same thing to the other side. And it's going to give me 9 subtract 3 over 7. We'll go ahead and write 5x equals, and you know that this is a 0, equals 9 subtract 3 over 7. I'll rewrite the right-hand side of that equation as 9 over 1 subtract 3/7. You know, to add or subtract fractions, you have to have a common denominator. And in this situation where we have a 1 in the denominator here and a 7 here, we need the lowest common multiple. And that's going to be 7. So I'm going to multiply this denominator by 7. That gives me a common denominator. But if I multiply only the denominator, it changes the value of this term. So I'm going to go ahead and multiply the numerator by 7 at the same time. You'll recognize that 7 divided by 7 is 1. And whenever we multiply any number by 1, we get the same number back. It's just going to look a little bit different. That's called the multiplicative inverse. Pardon me, the multiplicative identity. So now we have 5x equals, and to multiply those two fractions, you multiply straight across. 7 times 9 is 63. 7 times 1 is 7, and then we still have this subtraction of 3/7, and now we can just do the subtraction in the numerators. 63 subtract 3 is going to be 60 over 7. Let me get a new page. So at this point we have 5x equals 60 over 7. Whenever we're trying to solve this multiplication problem like this, we're going to divide or we're going to multiply by the reciprocal of 5. And since I've got these fractions, I'm going to go ahead and make both sides of the equation into rational numbers, ratios like this, keeps me honest. Now 5 divided by 1, to turn that 5 into a 1, which is what we want, going to multiply by 1/5, and then we have to multiply the other side of the equation by 1/5 to keep this equality true. This is the multiplicative inverse, and you know that's just 1. So now we have x equals, and we're multiplying these fractions on this side, multiply straight across, we'll get 60 over 35. And from the 6th grade, you'll recognize that this is an improper fraction, so we're going to go ahead and convert that into a mixed number. I'll rewrite 60 as 35 plus 25, and we're still dividing by 35. And that's going to be 1 plus 25 over 35. Since both this numerator and this denominator has 5 in the ones place, we can write that now as, we can factor 1 plus 5 times 5 over 7 times 5. The 5's cancel out, and that leaves us 1 plus 5/7, and we can write that as a mixed number, 1 and 5/7. Box in our answer. That's the first way of doing these. If you're really comfortable with fractions, you're more than welcome to do it that way. As we do these problems in class and you're doing them as homework, keep everything as a fraction, because when you get to the 9th and 10th grade and you're in Algebra 1 and Algebra 2, you're going to be doing a lot of work with rational numbers, rational expressions that have both numbers and letters in them. So if you practice working with your fractions here in the 8th grade, be a lot easier once you get to the 9th grade. And that's one of the things that we're trying to do, is prepare you to be successful in the higher grades. Now we're going to go to the second technique. And before we start on the second technique, it's good if we review something called the distributive property. Here we have 3 times 25 equals 75. To demonstrate the distributive property, I'm going to break this 25 down into component numbers. So I'll make it 13 plus 10 plus 2. This is just as an example. And that has to equal something. We know that since 13 plus 12 plus 2 equals 25, whenever we do this demonstration with the distributive property, we should get the same answer if we did everything right. Now, the distributive property says that we multiply everything inside the parentheses by this 3. And to remind myself that I'm doing all the multiplications, I draw these golden arches like this to remind myself to do that. Now we're going to distribute 3 times 13. We'll write it as 3 times 13, add 3 times 10, add 3 times 2, and hopefully that equals 75. 3 times 13 is 39. 3 times 10 is 30. And 3 times 2 is 6. 39 plus 30 plus 6 is going to be 39 plus 36. And if my addition is okay, that should be 75. 75 equals 75. Since we got this identity, that means that all the work that we did over here is correct. It's always good to check at the end of the day that you've got this identity, so you know that all the work you did was proper. Now we'll use this distributive property in this second technique. So here we have the same equation that we had in the first technique. And what I'd like to do, because fractions are so traumatic for me, I need to get rid of that denominator. I mean, that's what makes a number a fraction, is having a denominator. And to do that, we're going to multiply this entire equation by 7 over 1, because this is really 1 times 3 over 7. And since I'm working with fractions, I'm going to make everything into a ratio, a rational number. And then I'm going to draw brackets around this entire equation. And I'm going to multiply everything by 7 over 1. I call this the up, down rule. We have a 7 that's down. To get rid of it, we have to multiply by 7 that's up. So up, down rule. To get rid of that denominator, I'm going to multiply by 7 over 1. And now I'm going to distribute that 7 over 1 over everything inside that equation. I'll write down every step to avoid making mistakes. But I know I make mistakes anyway. So now we'll just do the arithmetic. 7 times 5 is 35. That's going to be x. These 7s cancel out when we do this. So now I have 3 over 1. And multiplying fractions, we multiply straight across. So I have 63. For the time being, I can get rid of those denominators. 35x plus 3 equals 63. Now this looks exactly like what we did in the first video on this. So we had 35x plus 3 equals 63. And once again, it makes our life a lot easier if we zero out this constant term. You don't have to. You can divide by 35, but as soon as you do, you're back into fractions all the way across. So I'm going to zero out that 3. We'll have 35x, add 3. To zero him out, we add the opposite. And since we added a negative 3 on the left-hand side of the equation, we have to do the same thing on the right-hand side. It's going to be 63 subtract 3. The additive inverse says that's a 0. And now I have 35x equals 63 subtract 3 is 60. I'll go ahead and rewrite everything as a rational number because I'm going to multiply this equation by 1 over 35. I do that to cancel out this 35 so it becomes a 1. And I have to do the same thing on the other side of the equal sign. The multiplicative inverse gives me a 1. So now I have 1x equals 60 over 35. It's an improper fraction. We're going to rewrite that as a mixed number. So that'll be 35 plus 25 over 35. This 25, I got that by subtracting 35 from 60. This equals 35 over 35 plus 25 over 35. Thirty-five divided by 35 is 1. And once again, we have 25 over 35. And 25 divided by 35. Since we have a 5 in the ones place, in both the numerator and the denominator, we can factor out a 5. 25 is going to be 5 times 5, and 35 is going to be 5 times 7. The 5's cancel out and leaves us 5/7. So then at the end of all of this excruciating work, we get 1 plus 5/7, and writing that as a mixed number will be 1 and 5/7. Same answer that we got the previous time. That's good. The first 3 times I did this video, I didn't get the same thing, but I got it that time. So, summary. You have 2 techniques to solve a multiplication and addition problem with fractions. In the first technique, we zeroed out this entire constant term by adding the additive inverse, and that just got rid of that, showed up over here. I won't go through the whole thing. You can go back and review. That was the first technique. And the second technique, we had 5x plus 3/7 equals 9. And in this case, instead of getting rid of this whole fraction in one step like that, all I did was get rid of the denominator. Once I get rid of that denominator, I have whole numbers all the way across, and we solve the fractional part of that at the end. We don't have to deal with fractions the whole time that we're working the problem. Remember, we multiplied everything by 7, and we got 35x. And the reason we multiplied by that 7 is to get rid of that denominator. I called that the up-down rule. And there we are, about halfway through that problem. Encourage you to go back and review each of those techniques, determine which one you like the best, right? And then you're more than welcome to use either one. Sometimes it'll be easier to do one technique, and other times it'll be easier to do the other technique. It just takes a little bit of practice, maybe a lot of practice, to see in advance which one that you prefer to use. So at the end of the day, there's only one thing left to say. You know it. And that is, that's all, folks, F-O-L-K-S. I'm fond of putting an R there for some reason. Thanks for listening. Thanks for learning. Be safe. Con cuidado.